Point your phone at a friend walking across a room, one shaky handheld clip. No special rig. A 2026 method called 4DAnyone turns that single casual video into a full four-dimensional human, one you can orbit around and scrub through time. That fourth dimension is time on top of three-dimensional space, so you get a moving view-from-anywhere reconstruction. Let's see how it pulls that off from one uncalibrated camera. So how do you get a full 4D human from one wobbly clip? 4DAnyone runs 4 moves. Follow them in order. Start with the input and notice how little it demands. Just a casual monocular video, one camera, mild handheld motion, unknown lens settings, unknown camera positions. There is no calibration, no multi-camera stage, no motion capture suit. This is the kind of footage anyone already has on their phone. Next, it imagines the missing angles. A video generation model synthesizes new target views of the same person, essentially filming them from cameras that were never there, so the system has many viewpoints to reconstruct from instead of the single one you actually shot. Now the hard part, keeping all those invented views agreeing with each other. Push a diffusion model past the handful of views it can hold at once and the extra ones start to drift and contradict. 4DAnyone fixes this with 2 designs it calls reference context packing and target context routing, which keep appearance and global structure consistent across dozens of views. Finally, it lifts everything into 4D Gaussian splatting. All those consistent views get fused into a splatting model that represents the person as a cloud of tiny elements evolving over time, giving you a reconstruction you can render from any angle at any moment in the clip. Now, why did nobody just do this with an off-the-shelf video model? Put the naive way against 4DAnyone. A plain camera-controlled video diffusion model can dream up one convincing new angle at a time. But 4D reconstruction needs tens of views that all agree, and once you ask for more than a single pass can hold, the model splits them into groups and the groups start to contradict. The result looks plausible frame by frame but won't fuse into a solid shape. 4DAnyone treats the consistency itself as the problem to solve. It packs the reference views into a fixed-length context so appearance cues are never lost, and it routes the target views so global structure propagates first and fine detail is refined after. Now the dozens of views hold together well enough to reconstruct. Strip it down, and 3 things make 4DAnyone stand out. It works from casual, uncalibrated footage. No rig, no known camera, no capture stage, which is exactly what separates a lab demo from something you could point at everyday video and expect to work. Its real contribution is view consistency at scale. The insight that generating many agreeing views is a context capacity problem, and the 2 designs that solve it are what let a video model feed a genuine 4D reconstruction. It reportedly generalizes in the wild. On human-centric benchmarks, the authors report beating prior methods on both novel view quality and the downstream reconstruction, while still handling diverse real footage rather than only clean studio clips. Alright, let's lock in what matters. 4DAnyone reconstructs an animatable, view-from-anywhere 4D human from a single casual monocular video. No rig or calibration required. It generates many novel views of the person and lifts them into 4D Gaussian splatting, a cloud of tiny elements evolving over time. Its core trick is keeping dozens of generated views consistent via reference context packing and target context routing, so they actually fuse. The takeaway is that view consistency, not raw image quality, was the real bottleneck. If you like this kind of teardown, come spend a few minutes with us at Standarity.com.